Okay, this is a Doppler shift question for a grade 11 class, question 41 from your worksheets. This asks a little bit different now. We're given two frequencies. We're given the observed frequency and the frequency of the source, and we're trying to figure out how fast an object must be moving. So let's read through this carefully. What is the speed of a truck in kilometers an hour if the driver hears a frequency of a police car to be 1.77 times 10 to the 4 hertz? The police car is driving 139 kilometers an hour. Its siren has a frequency of 1.4 times 10 to the 4 hertz. The speed of sound is 334. Okay. So the truck is the observer. So anything relating to the truck is going to be labeled observer, OBS. Anything related to the police car is going to be labeled source. Okay, so we have to be very careful here in how we're labeling this out. We're trying to find the speed of the truck. The truck is the observer. So velocity of the observer is our question mark. Velocity of sound, we'll just get to that right away since we know exactly what it is, 334 meters per second. It's just a cool day. The observed frequency is 1.77 times 10 to the 4 hertz. So that's 17,700 hertz. The emitted frequency, the frequency of the source, is 1.4 times 10 to the 4 hertz. And the last thing is how fast the source is moving, 139 kilometers an hour. All right. So lots of little business to take care of first before we get into the big problem. This can be done with our regular Doppler shift equation. Not too bad, actually. The math isn't too bad, but the numbers here have to be all consistent. We can't use the speed of sound to be 334 and the velocity of the source to be 139 kilometers an hour. We need to make those both meters per second or both kilometers an hour. Okay. We're used to working in meters per second, so I'll work with meters per second. So the velocity of the source, which is the cop car, SRC for source, is 139. Divide that by 3.6 to give us meters per second. 38.6 meters per second. Okay, that's not too bad. Everything else is the same. Now we need to decide what equation are we using. It's the same setup. Observed frequency is the frequency of the source times the sound frequency, and then I'm going to leave that blank. Velocity of observer over speed of sound, and then we have the velocity of the source. I need to know whether we add the numerator values together or whether we subtract the numerator variables together. The answer to what equation or what form of the equation you use lies in the observed frequency and the source frequency. The observed frequency is greater than the source frequency, which means these two objects have to be going together. So the equation becomes that. Positive on the numerator and subtraction in the denominator. So now we can put our values in and be very careful with our mathematics. We'll be able to figure this problem out. So observed frequency, 1.77 times 10 to the 4 equals the frequency of the source, 1.4 times 10 to the 4 times speed of sound, 334. Plus the velocity of the observer. That's what we're trying to figure out. Over the speed of sound, 334 minus speed of the source. Remember, use your meters per second, 38.6. Simplify what you can. To make it a little bit easier, I'm going to divide both sides by the 1.4 times 10 to the 4. So I'll do this in a couple of steps. So 1.77 times 10 to the 4 divided by 1.4 times 10 to the 4 is 1.26. So again, I'm not writing that all down, but I divided both sides by the source frequency, 1.4 times 10 to the 4. So what I'm left with on the right is 334 plus the observer's velocity over, do that subtraction, 334 minus 38.6 equals 295.4. So the variable we're trying to solve for is in the numerator. It's stuck in the numerator. I'm going to kind of multiply both sides by the 295.4, or cross multiply if you want to think of it that way. 372.2 equals 334 plus my observed frequency. Okay, so again, I multiplied 1.26 by 294. Now I subtract the 334 from both sides, and I'm almost done. 38.2 equals the observer's frequency. Now that is in meters per second, and the question asks for kilometers an hour. So in kilometers an hour, I multiply that by 3.6. So 38.2 times 3.6 gives us 137 kilometers an hour. Right. Summarize it. Velocity of the observer would have to be 137 kilometers an hour.